Greetings of the day. Welcome to the video lectures. I am G. Muthugurunathan, working as Assistant Professor in the Department of CSE in Madanapalli Institute of Technology and Science. Greetings of the day. Welcome to Madanapalli Institute of Technology and Science. Now we are going to see the conversion of NFA to DFA, that is non-deterministic finite automata into deterministic finite automata. So before that, I want to show you what is mean by finite automata. So finite automata, in the sense, it is the automation technique which is accepting the input string depends upon the patterns. Okay. So then there are some types are there in finite automata. So what are the types is, so first one is finite automata without output, and the second one is finite automata with output. Okay, so then in finite automata without output, again we are having three more types over here. So what are those is, the first one is DFA, the second one NFA, and the third one is NFA with epsilon modes. Okay, and when it comes to the finite automata with output, we are having two types, that is Mealy and Moore circuits. Okay, so now in this lecture, what we are going to see is how we are going to convert the NFA transition into DFA. Okay, so what is mean by NFA is, that is non-deterministic finite automata. This finite automata having the property of it is accepting the same input for the different stage. Otherwise, in the sense, it may be accept. So now you can see this. So here Q0 is the one state, Q1 is the another state. When we are giving the same input, it is reaching to two different states. This is called as an NFA. But when it comes to the DFA, what will be there means, for a one state, each one is having the unique state. So that means if Q0 is accepting A input and it is reaching to Q1, means one more time it will not accept the same input. Okay, so this is what the main difference between NFA to DFA. Now we are going to see how we are going to convert one NFA diagram into DFA diagram. So let me take one basic example over here. So let me show you one basic example. This one is actually a NFA diagram. Why? Because there are three states available: the Q0, Q1, and Q2. In Q0, you can see this. We are having A input and it is reaching the same state. And one more thing, again I am passing the same input and then it is reaching to Q1 state. So it definitely it is showing the NFA diagram. And one more thing is when I'm reaching the Q1 state, I'm having the input of B. When I'm reaching the input B, it is reaching to the Q2 state, but there is no input for the A symbol. So this is the NFA diagram, clearly it is showing. So now we are going to convert this NFA diagram into DFA diagram. So, so for the DFA diagram, what is there means each state should have all the input symbols. So that means for the Q naught, we need to apply all the possible input symbols available in the NFA. That means A and B, both we have to apply to the Q naught as well as Q1, Q2. Each one is giving the unique output states also. That is what we are going to convert into a DFA diagram. Okay. So before going to that, we are having the 5 tuples in the finite automata that we are going to see now. So 5 tuples here. So these are all the 5 tuples available in the finite automata. Okay. So here, what is meant by Q is it is a finite set of states. What are the total number of states? It is available in the Q. And then when it comes to the sigma, this is sigma. It is containing all the input symbols. So here, what are the states available here is, so Q is equals. So here there are 3 states available. That is Q naught, Q1, and Q2. This is the 3 states available in the NFA diagram. And then when it comes to the sigma, this is set of input symbols. Okay, so what are the input symbols available here? A and B. So when it comes to the Q2 also, we are passing 2 input symbols like A and B only. So this is the 2 input symbols we are having. The next one, it is delta transition. So delta transitions is nothing but a mathematical formulation. When we are having the input symbol in Q naught, what may be the next state? That is for the delta transition, which we represent as a mathematical formulation. Okay. So delta can be defined by delta of the current state. So what is the current state I am taking is Q naught. Okay. And what is the output input I am going to apply for the Q naught is A input. Okay. So this is the mathematical formulation for delta transition. So Q naught is the current state and A is my input symbol. So when I am applying A into Q naught, what is my next state is I am reaching Q naught and Q1. There is 2 states available. So if it is 2 states, I need to apply this one. So now when I am reaching Q naught and then I am applying the input symbol A, I am reaching 2 next states, that is Q naught and Q1. Same way, if I am applying Q naught comma B, so you can see this Q naught comma B, there is no transition available. That means we can apply null symbol because there is no next state available for Q naught when we are implementing B input. So same way, if we go for next state, it is Q1 comma A. So when we are reaching the Q1 state and we are applying the A input, there is no next state. So that means here also null will come. The next one is delta of Q1 comma B. So which is what will be the next state? Q1 comma B is when we are reaching the B input, it is going to the Q2 state. Q2. Okay. So now we applied for Q naught and Q1 with all the possible inputs. Now we move for the Q2. So delta of Q2 comma A, which is equals. So where we are applying when we are reaching Q2 and my input is A, which state I am reaching is same Q2 only. And when I am applying Q2 comma B, which state I am reaching is same Q2 state only. So this is for the mathematical formulation of finite automata. Okay. So now the next one is Q naught. So Q naught is nothing but it is the starting state. So in my case, in this NFA diagram, what is my starting state is Q naught. Why? Because how I am representing the starting state is, you can see this, there is no input symbol or next previous state. Without that, one arrow mark is representing. So that is what the starting symbol of the finite automata. So in my case, my starting state is Q naught only. And finally, F. So F is nothing but it is a final state. So as per this NFA diagram, what is my final state is this Q2. Why? Because always the final state will be encircled with two circles. Okay. So my final state is Q2. So this is what my 5 tuples available in the finite automata. Okay, so this is what my diagrammatical representation of finite automata, and this is delta transition. This is the mathematical foundation representation of my finite automata. And one more thing is there, that is transition table. So transition table is nothing but transition table is nothing but it is a tabular column method, that is rows and columns. In that way, we can able to represent my details. So let me see how we can represent. So my Q0, Q1, Q2, I have taken all the states in the row wise, and what are the inputs I am having, A and B, that we can represent as a column value. So now you can see this. This is a rows and columns. In row wise, we are having the different states, and column wise we are having the input symbols. So when I am applying Q0 and A input, what is the state I am reaching? I am reaching Q0 and Q1. So that means Q0 comma Q1 will come. And when I am going for Q0 comma B, there is no transition available. So that means here none. Okay. So next one's Q1. So for Q1, A input, there is no transition. So it is coming null symbol. And Q1 comma B, I am reaching the Q2 state. So here Q2. And the next one is Q2 comma A and Q2 comma B. So for both inputs, I am reaching the same state. It is Q2. It is Q2. So this is what the 3 types of representation of the finite automata. So the first one is, it is a diagrammatic representation, that is transition diagram. And second one is my transition function using mathematical formulation. And third one is transition table. So now I'm going to convert this NFA to DFA diagram, which means that whatever the null symbols we are applying here, that should not come. Instead of that, we are going to apply some input symbols. Okay. So now I'm going to start to convert NFA to DFA diagram. For this one, I need to start with my starting symbol. For each new identified next state, I need to apply all the input symbols. Okay. So now I'm going to start with my input symbol Q0. So why? Because I am starting with Q0 is Q0 is my starting state. That is the reason we need to start always from for the NFA to DFA conversion Q0. So delta transition of Q naught comma A. So what is equivalent to Q naught comma A is we are having two states, Q naught as well as Q1. So we need to identify the transition of Q naught comma A is Q naught and Q1. So now you can see this. We have applied the first input symbol A. Then next one we need to apply the second input symbol B, but there is no transition for the Q naught. So delta of Q naught comma B is equivalent to null. Why? Because there is no transition for Q naught with input symbol B. Now we can see this. We have identified one new next state. So now we need to start with this new next state and we have to apply the both inputs, that is A and B. So here you can see this delta transition of Q naught comma Q1 and we need to apply the first input symbol A. So now you can see this directly we cannot apply Q naught comma Q1 and A. So what I do is I am splitting this Q naught and Q1 and finally I am merging these two. So delta transition of Q naught comma A union delta transition of Q1 comma A. So again you can see this Q naught comma A, what it is coming again? Q naught comma A, it is coming again Q naught and Q1. Union, again you can see this Q1 comma A. So Q1 comma A, there is no transition, which means it is null symbol. So that is I am having the transition of Q0 comma Q1. Okay, so now we go for the next input symbol B. So delta transition of Q0 comma Q1 B. So now we are going to apply the B input symbol. Okay, so here also again we can split the state and then we can finally merge the values. So delta transition of Q0 comma B union delta transition of Q1 comma B. Okay, so now we can apply Q0 comma B. So here you can see this for Q0 there is no next state when we are applying the B input. So here it will come null and union. What is the next input state is Q1 state and we are applying the B input. What next transition we are getting is Q2. So here it comes Q2. So the final after the union we will get Q2. Okay. So now what we are getting is we are getting Q0 comma Q1 is the new state identified when we are applying Q0 comma A and we have applied the input symbols for Q0 Q1 A and B Q0 Q1 state. Now you can see this we identified the new next state is Q2. Okay, so when we are applying Q0 comma Q1 again it is coming same state only. Okay, so if it is identified the repeater states there is no need to go for the input symbols again. Okay, so when we identify one new next state then again we have to go for the application of my input symbol for the new state. Okay, so now I'm having the new state is Q2. So again Q delta transition of Q2 comma A is so Q2 comma A is the same state Q2 and the delta transition of Q2 comma B is again Q2 only. Okay, so now we have identified the delta transition for the DFA diagram. Okay, so now we can go for the delta transition diagrams. Okay, so what are the states available here is the first state is the first state always we have to start with Q0. So this is my first state, and then when I am applying, I have identified the one new state Q0 Q1. This is my second state, and when I am applying Q0 comma B, I am identifying null only, so there is no states. And then when I am applying Q0 Q1 with A input, I am identifying the same state only. And when I am applying Q0 Q1 with B input, I am identifying the next state called as Q2. Okay, and for Q2, A and B same next state only. So totally, I am having three states now. Okay, so among this one, what is the starting state is always what are the starting symbol for the NFA diagram, the same for the starting states for DFA diagram also. So let me start my DFA diagram over here. Mm. So what are the states identified here is we have identified Q0, and then Q0 comma Q1 is the another one state, and then the next one is Q2. Okay, so now step by step we need to apply the input symbols for each state. Okay, so now when I am applying Q0 with A symbol, where I will reach is Q0 Q1 state. Okay, so when I am reading the B input in the Q0 state, there is no transition as per this NFA diagram. So one new state we have to implement here, that is called as null state. When there is no next state, we need to reach the null state. As per the DFA definition, what the definition is, every state should have the all the input symbols and it should reach the unique next state. Okay, so when I'm applying Q0 comma B, it should come null symbol. So now you can see this for Q0 comma A, it is reaching to the Q0 Q1 state. When I am Q0 reading the B input in the Q0, I am going for the null symbol. Okay, same way we can go for the remaining next states. So when go for the Q0 and Q1 with A input symbol, it will remain same state only. Okay, now when I am applying Q0 Q1 with B input symbol, it will reach to the Q2 state. Okay, so this is what the next new state identified, and you can confirm that for Q0 A and B input symbol we have reached, and then for Q0 Q1 A and B symbol we have reached, and the last next state is Q2. For Q2, when I am applying A comma B input, it is reaching to the same states only. Okay, so this is what the final DFA diagram for the given NFA. And one more thing, as per this finite automata tuples, we can identify the set of tuples are for M. Okay, so for M, we have the 5 tuples. For the Q, what it will come here? It will come Q0, 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 Q1, and then Q0, and then null symbols. And then next one is sigma. The sigma is set of input symbols, that is A comma B. And then delta transitions already we have identified in the last thing. And then what is my starting state? So starting state is always my NFA starting state. It is we are started like Q0. So here Q0 will come, and then we need to identify the final state. So the last one is final state Q2. Okay, so why? Because it is Q2. In NFA transition diagram, we have the final status Q2. So that is the reason when we are converting it to the DFA diagram, wherever the same final state coming, it is also a final state. So here in this case, Q2 is my final state. Okay. So these are all the 5 tuples identified in the finite automata for given DFA diagram. Okay. So hope all of you understood very well. Thank you. We will see in the next lecture.